So the strictly determined from section 7.4, let's do one last example. This matrix is for these pizza parlors, Dino and Sal, and this is whether they have a special or not. If they have no special, that's this first column and first row, but they could have a special on mini pizzas or medium pizzas or a drink, and this is the number of sales. Remember, this is with respect to Dino. So positive means that if Dino had no sale at all, and Sal had no sale at all, then Dino would sell 200 more, I guess. If Dino had no sales and Sal had a mini pizza sale, then Dino would be 400 less than Sal, etc., etc. If we use our method here, look for the mins. For this row, negative 600. For this row would be the 100. For this row, negative 300. And for this row would be the 0. For the maximums, for the columns, this column maximum would be 500. This column maximum is 100. This column maximum is 400, and this column maximum is 600. The maxi-min, the maximum value for all these minimums, is the 100. The minimum for all these maximums is 100. So this, once again, is strictly determined, what we're doing in 7.4. And this gives you what they should do, their strategy. So they should both be selling these mini pizzas on sale. Put those on sale. But if for some reason Sal chose to put, the drinks on sale, then Dino should stick with these mini ones. You could use this table, and if you say Sal's trying something he shouldn't, you could go along with that and figure out what's going on here. So this tells both Dino and Sal what they should do. Whether they do that or not certainly is another question. So now from 7.5, this game theory part 2, we look at when we have no one way of doing something. Suppose Sal, with this heads and tails stuff, and the heads and tails for Tina. And suppose if you get 2 heads, then Sal gets 3 cents. And if you get 2 tails, then Sal gets, 1 cent. But for Tina, would get 2 cents if it's heads, tails, or tails and heads. So now, what is the best strategy for these? So we take the minimums for the rows. This is a -2 and a -2. The maximums for the columns. This is 3 and this is 1. The maxi-min, well, we've got 2 choices here. And the mini-max is the 1 here. So Tina should still always do tails. But now Sal has a choice here, because you could use either one. There is no saddle point, and maybe the best strategy is to keep mixing these up, heads and tails, to see if sometimes Tina might change, although Tina shouldn't. So you want to make sure you have the other player maybe guessing. Toss a coin or roll a die to see whether you choose heads or tails. Suppose both Tina and Sal would, flip a coin to see what they play. You could look at the expectation for the winnings as far as Saul is concerned. If we take a look at Saul's and say, what is the amount won? Well, they could win either 3 or 1 or maybe the -2. That's what Saul could win there. What is the probability? The P of X. This could be like the X, the amount won. The P of X. Well, now it all depends. I guess if we're flipping a coin and we'd have to say the coin is 50-50, then it's really going to be 0.5 times 0.5, because we have 2, which is 0.25. Sorry. And for this, it's also 0.25. But because we have 2 situations where we could lose that, you add those together, and that's 0.5. This, in this case, should add up to 1. Now if you take x times P of X and multiply those together, here you get 3 times 0.25 or 0.75. Here you get 1 times 0.25. And here you get a -2 times 0.5. Well, it comes out to 0, which is what you can expect to win. It's called the expected value, or the expectation. You have to figure out all your winnings and losings, and this would be a fair game. But notice it was a little confusing just for this small one. When it gets to be a lot bigger, it can be a little more confusing. So let's use a little bit of matrix algebra to figure some of these out. If Saul was doing sort of 50-50, half the times choosing heads, half the times choosing tails, this is the payoff matrix. When you multiply these together, remember this is a 2 by 1. I'm sorry. This is a 1 by 2, 1 row and 2 columns. This is a 2 by 2. So these are conformable, and the answer will be a 1 row by 2 column matrix. So to get the first row, first column, use the first row, first column. 3 times 0.5 is 1.5. -2 times 0.5 is -1, so this we get 0.5. For the second rows, first row, second column, use the first row, second column. This is a -1 and this is 0.5, so the -0.5 for this. And so these are the heads and tails. If we add the row, we do get 0. So this is a fair game. What does this mean? If Saul does a 50-50, heads and tails, then if Tina plays heads, Saul gets 5 cents. And if Tina plays tails, Saul loses 5 cents, or Tina gets 5 cents. Saul is a -5. And if they do this an infinite number of times, then it comes out to be that 0 eventually. Suppose, though, Saul changes his strategy a little bit. Suppose Saul says, you know what? I'm going to do heads about, 60% of the time. Come up with a way of doing that, and 40% of the times with tails. then what can I expect to get? I'm sorry, this is multiplication. That 3, -2, and a -2 and 1. When you multiply this out, and you get your 1 row, 1 column, you get 8.1 and a -0.8. I'm sorry, this is not 0.1. This is 1 and a -0.8. Because you do this row and column. This is 1.8 and this is -0.8. So it's 1, not 0.1. This is a -1.2 and this is a +0.4. So that's the -0.8. So once again then, in this case, if Saul plays a heads, then he should get $1. And that's if Tina plays tails too. Plays heads too. If Saul plays tails and Tina plays tails, then this should be 80 cents that they lose, that Saul loses. Together though, this one now comes out to be a +0.2. So in the long run, he would win 20 cents.